Welcome to Brain Vision.
So we have two wires, one with current I1 on the left here flowing upwards, and then we want to find, given an attractive force between these two wires, and that force is 7.8 times 10 to the minus 4 newtons per meter, since these are infinitely long wires. Given that, we want to find then what current I2 must be flowing through this second wire here. So first off, this is an attractive force. And so to find the direction for I2, we could use the right-hand rule for the force acting on an electron. But we can probably just remember as a universal rule, if we have constant current flowing through wires, if the wires are attracted to each other, that always means the current is in the same direction. So if they repel, currents are in opposite directions. If they attract, it's in the same direction. So I think we'll just use that fact here. So that means that I2 must also be going upwards in the positive direction there. So we have a force, really a force per length here. But we know in general that the force acting on a wire is just going to be the current in the wire times the length of the wire L, and then times the magnetic field. So if we have a force per length, we know that force equals this, so then we need to divide this by the length also, since really we're saying force equals ILB, then divide both sides by L. So we actually just lose that L over there. So we have our force per length now equals this value equals I times B. And so that's I2, which is what we're trying to find over here. And now we just need to know what is the magnetic field that's acting over here. But we know that for an infinitely long wire, so this would be I1 now, the magnetic field that it'll make is just mu naught I over 2 pi r. And then this is I1, since we're thinking about the magnetic field made by wire 1 over here. So then we just plug in our value for r, so the separation between the two, 7 centimeters, and we can get I2 by itself. So it looks like that should equal our force per length value, 7.8 times 10 to the minus 4th newtons per meter. And then that'll be divided by mu naught I1 and times 2 pi r, where r is 7 centimeters. And so we do all that, and we should get about 9.75 amps. And so that'll be in the upward positive direction.